In this video, I'm going to tear down a Bose 700 headphone to show the internal construction and to study the touch sensor. Before I start, let me talk a bit about projected capacitive touch sensor, which is the type used in the Bose headphone. Projected capacitive sensors project electric field from the transmitter electrode and then measure at the receiver the electric field reflected by the finger on top, hence the name projected capacitive sensor. This method of sensing, when implemented with rows and columns of scanning, can detect multiple touch with very high resolution, and therefore it has become the standard technology for the 2D touchscreen and trackpad. Here, I have a Bose 700 headphone, and the touch interface is also implemented with a projected capacitive sensor. The main user interface of this headphone is swiping up and down for the volume control. Whether the swipe is fast or slow, the sensor can detect the gesture correctly. This might not seem like a big deal, but engineers would appreciate that it is the high-resolution detection that makes this possible. Another user interface is swiping left and right, and to applications such as an audio player, this can be used for the skip forward-backward function. Also, there is a double tap function for toggling between pause and play, and a press and hold function for reading the battery life.
Battery 6 hours.
Now, let me tear down this $300 headphone so that you don't have to tear down yours or even to buy one to do so. This is the view of the compartment inside the headphone. On the touch area, we can see a FPC pasted on the casing. With only tracers and pads on the FPC, it is obvious that this is the electrodes for sensing the touch. The sensor IC is hidden underneath the main PCB, so let me remove the PCB and see what is beneath it. Okay, it is a 28-pin QFP IC with a top mark IQS572. From the datasheet on the website, IQS572 is a 8-row by 9-column projected capacitive trackpad controller, capable of sensing 2048 points by 1792 points. Based on the application circuits and description, all that is needed are rows and columns of diamond-shaped electrodes plus some passive components, and the IC will detect and report the XY coordinates of multiple touch to the host MCU. From the actual implementation of this headphone, we see 4 rows and 9 columns of electrode being used, and the resolution is about 2000s by 900s, which is more than enough for gesture detection. At the back of the touch electrodes, we can see some mesh ground plane. Ground plane is normally used for shielding purpose, but excessive ground plane can also reduce the sensitivity, so mesh structure is used instead of solid plane to provide balance between shielding and sensitivity. Another interesting observation is that the touch surface is a 3-dimensional curved surface, and the FPC is able to conform to the 3-dimensional shape of the plastic. The length of the tracers to the rows and columns are different, and so is the area of the diamond electrodes. This will result in some differences in the raw signal when the same touch is applied to different locations. Luckily, as I understood it, the controller can adjust the threshold and the gain for each node so that the overall sensitivity is consistent over the entire touch area. While we are at it, let's take a look at other components in the headphone. Here we see 3 MEMS microphones on this side of the headphone and another 3 on the other side. The microphone points towards the front and the back to pick up the ambient noise for the noise cancellation. With 6 mics working together, the array structure has a strong directivity, picking up the voice signal from the front and suppressing the ambient noise from other directions. The sampling and pre-processing of the audio signal is performed by the IC AD71158. The main processor is a Qualcomm CSRA68105 Bluetooth Audio SoC. This IC does the system control, reads the touch gesture, performs the signal processing, sends and receives audio data through its built-in Bluetooth. The battery is located inside the left headphone. Now back to the touch sensor. Projected capacitive touch sensors have a surprising characteristic. The capacitance decreases as the finger gets nearer to the electrodes, and this is totally opposite to our intuition. Although theoretically complicated, the application of projected capacitive touch sensors has never been easier, thanks to the competitions resulted in many vendors making modules available. Thank you for watching, and as always, please like, share and subscribe.